Question 7. The displacement x of a particle at time t is given by x equals 5 sine 4t plus 12 cos 4t. What is the maximum velocity of the particle? The displacement equation x equals 5 sine 4t plus 12 cos 4t. Now, the velocity is the rate of change of displacement with respect to time. So to get the velocity equation, we differentiate the displacement equation with respect to t, and we need to use the chain rule in this case. So differentiating x with respect to t, we get v equals 20 cos 4t minus 48 sine 4t. Notice that we have a difference of two trigonometric ratios, namely cos and sine, where the angles are identical. So we can write this using a compound angle identity, in this case, the cosine of the sum of two angles. So we can write v as the square root of 20 squared plus negative 48 in brackets squared times cos of 4t plus alpha, where alpha is the auxiliary angle. Now we don't need to know what alpha is at this point. The question is asking for the maximum velocity of this particle. So moving on, if we evaluate the square root here, which represents the amplitude of this function, we get 52. And we multiply that by cos of 4t plus alpha. So the maximum value of this function is equal to its amplitude, which is 52. If we want to consider the range of this function, 52 cos 4t plus alpha will range from negative 52 to positive 52, inclusive of the endpoints. And that's because cos 4t plus alpha itself will range from negative 1 to positive 1. And so we're multiplying that by the amplitude. So the particle will swing from negative 52 to positive 52 and back again. So positive 52 represents the maximum velocity. Therefore, the correct answer is option C.